In this video, we're going to talk about how to find the domain and range of a function. The domain of a function is the set of all possible input values, and the range is the set of all possible output values. If we're looking at a graph, the domain would be the set of all possible x coordinates, and the range would be the set of all possible y coordinates. So looking at the first example here, we have the function a of s equals s squared, where s is the side length of a square and a is the area of the square. So for this function, remember the things that we want to think about are whether fractions and decimals are allowed, whether negative values are allowed, and whether 0 is allowed. So for my domain, I'm thinking about what the possible inputs could be. Now, I could have a fraction or decimal value for side length. I could have a square that has, for example, sides that are 2.5 centimeters. That would be okay. I could not have negative values because it wouldn't make sense to have a negative number for side length, and it also wouldn't make sense to have 0 for a side length. So for my domain, I'm going to say that s has to be greater than 0, not greater than or equal to, just greater than. Or another way I could write this is that the domain is any number greater than 0. Now for my range, we're looking at the possible output values. So for area of the square, I could have an area that is a fraction or a decimal, but I would not have an area that's a negative number, and it also wouldn't make sense to have an area of 0. If there was an area of 0, there wouldn't be any square there. So I'm going to say that area also has to be greater than 0. Or again, I could write out any number greater than 0. Now number 2, this one is the function r. r of n equals 40n, where n is the number of campers. We saw this example earlier with the tennis camp. They charge $40 per student, and the number of students would be between 5 and 16. So for this function, when I consider the context, it would not make sense to have a fraction or a decimal for the number of students because, well, that just doesn't make sense. It has to be a whole number. And then I'm also restricted by the situation where they're saying that they need to have at least 5 campers, but the limit is 16. So my domain in this case is whole numbers between 5 and 16. And this is represented on the graph by the fact that instead of having a smooth line here, what I have is specific points. So there's a point at 5, there's a point at 6. There's no points on the graph in between 5 and 6 because it doesn't make sense to have number of students anything between 5 and 6. It could be 5 or it could be 6, but I couldn't have 5.5 students. So that's my domain. Now, looking at the range is a little bit trickier for this one because, again, it can only be specific values. So I could have $200, which would be the revenue if there were 5 campers, because 40 times 5 is 200. So looking at this here, 200 is a possible y value, or a possible output, and the next one would be 240 if I had 6 campers. If I had 7 campers, it would be 280. So this is going to continue up until I get 16 campers. So if I do 40 times 16, I would find that that's equal to 640. You could do that on your calculator. So what's happening here is that the range can only be a multiple of 40. And the reason it's multiples of 40 is because this is the equation 40 times n, so it has to be 40 times a whole number to get these y values. Multiples of 40 between 200 and 640. So that would be my range.